In the vast expanse of the cosmos, Voyager 2, launched in 1977, has sent a mysterious signal that defies explanation. After reshaping our understanding of the solar system, the probe, now over 12 billion miles away, has transmitted a structured pattern buried in radio energy, detected by the Deep Space Network and sparking debate within NASA. The signal resembles a mathematical pulse echoing prime numbers, its precision impossible to dismiss as random noise. But if you're still here, you remember, you care. Hit like, subscribe, and tell me in the comments what part of this story feels wrong to you. And if you want to help others remember too, share this video on X, Facebook, Reddit, or even in your private circles. You're the reason truth still has a voice. Thank you. Voyager 2, beyond the heliopause in the interstellar frontier, detected something it was never designed to find. Its origin remains unknown. The scientific community is divided. Is it a natural phenomenon from undiscovered cosmic forces or a message from extraterrestrial intelligence? NASA has assembled experts in astrobiology, cryptography, and theoretical physics to decipher the signal, facing the task of unraveling a message that may redefine our place in the universe. The signal's structure resembles SETI protocols, hinting at a deliberate transmission from an intelligence-seeking communication. If natural, it could revolutionize astrophysics, offering insights into interstellar forces. Yet its precision suggests an order difficult to reconcile with known processes, raising the possibility of a remnant from an ancient civilization. As Voyager 2 ventures deeper into the unknown, carrying a golden record of Earth's sounds and voices, it leaves us with a haunting question. What is the boundary between our cosmic backyard and the rest of the galaxy trying to tell us? Voyager 2's journey symbolizes human curiosity and perseverance, launched during Cold War tensions as a testament to our ability to dream big. The signal may remain a mystery or herald a new era of discovery. For now, we listen, wonder, and wait, as the cosmos whispers its secrets to the loneliest traveler in the void. Section 1. The Cosmic Alignment. In 1965, a graduate student named Gary Flandreau discovered something extraordinary, a cosmic alignment that occurs once every 176 years. The four giants of our solar system, Jupiter, Saturn, Uranus, and Neptune, were slowly aligning in a perfect gravitational staircase. This rare configuration allowed for a spacecraft to leapfrog from one planet to the next, compressing a 30-year journey into just 12. The alignment was not merely a curiosity, but a celestial choreography that could revolutionize space exploration. Flandreau's calculations revealed that a spacecraft launched during this window could harness the gravity of each planet to slingshot itself to the next, gaining speed and efficiency with every encounter. This phenomenon, known as a gravity assist, had never been attempted on such a grand scale. NASA seized this opportunity and built two machines to ride this cosmic corridor, Voyager 1 and Voyager 2. These probes were designed not just to explore the outer planets, but to escape the solar system entirely, venturing into the interstellar medium where the sun's influence collapses and the galaxy's true environment begins. The Voyagers were equipped with state-of-the-art technology for their time, including cameras capable of capturing detailed images of distant worlds, spectrometers to analyze atmospheric composition, and magnetometers to study planetary magnetic fields. Each probe weighed approximately 773 kilograms and carried a golden record, a time capsule of human culture, including music, sounds, and images from Earth. The Voyager mission was not just a scientific endeavor, but a testament to human ingenuity and ambition. The probes were launched in 1977, a year that marked the beginning of a new era in space exploration. Voyager 1 was launched on September 5th, followed by Voyager 2 on August 20th, in a strategic sequence that allowed Voyager 2 to visit all four outer planets, while Voyager 1 was directed toward Jupiter and Saturn before continuing on a faster trajectory out of the solar system. The mission was a monumental achievement, requiring the coordination of thousands of scientists, engineers, and support personnel. But there was a catch. This alignment didn't just enable the grand tour of the outer planets, it also set the Voyagers on a trajectory into uncharted territory where the physics of space becomes stranger and more unpredictable. Little did NASA know that this same trajectory would one day bring Voyager 2 face to face with a mystery that challenges everything we understand about the cosmos. The outer reaches of the solar system are dominated by the heliosphere, a vast bubble of solar wind that stretches far beyond the orbit of Neptune. As the Voyagers ventured deeper, they began to encounter phenomena never before observed, including the termination shock, where the solar wind slows abruptly, and the heliopause, the boundary where the solar wind's influence ends and interstellar space begins. Observation. The termination shock was first crossed by Voyager 1 in December 2004 at a distance of approximately 94 astronomical units, AU, from the Sun. Voyager 2 followed in August 2007 at a slightly closer distance of 84 AU. These crossings marked the first time humanity had ventured into the outermost layers of the heliosphere. The data returned by the Voyagers revealed a turbulent region where the solar wind collides with the interstellar medium, creating a complex and dynamic boundary. Interpretation. The heliopause crossed by Voyager 1 in August 2012 and by Voyager 2 in November 2018 is a more subtle boundary. Here, the solar wind's influence wanes and the interstellar medium's plasma and magnetic fields begin to dominate. This transition is not abrupt, but gradual, with the Voyagers detecting a steady increase in interstellar particles and cosmic rays as they moved farther from the Sun. The heliopause is not a static barrier, but a dynamic interface that fluctuates in response to changes in solar activity and the interstellar environment. Speculation. As the Voyagers continue their journey, they will provide unprecedented insights into the nature of interstellar space. They may encounter entirely new phenomena such as interstellar clouds of gas and dust, or even the influence of distant stars. The data they collect will help scientists refine their understanding of the heliosphere's structure and its interaction with the galaxy beyond. Perhaps most intriguingly, the Voyagers may one day detect signals from other civilizations, though the chances are slim. Regardless, their mission has already redefined our understanding of the cosmos and our place within it. The Voyager's journey has been one of constant discovery. Voyager 1's encounter with Jupiter in 1979 revealed the planet's complex atmosphere, including its Great Red Spot, a storm larger than Earth. It also discovered active volcanoes on Jupiter's moon Io, the first time such activity had been observed on a celestial body other than Earth. Voyager 2's flyby of Uranus in 1986 unveiled a world tilted on its side, with a magnetic field unlike any other in the solar system. Its encounter with Neptune in 1989 revealed the fastest winds in the solar system and the existence of the Great Dark Spot, a storm system comparable to Jupiter's Great Red Spot. The Voyager's legacy extends far beyond their scientific contributions. They have inspired generations of scientists, engineers, and dreamers, reminding us of the boundless potential of human exploration. Their golden records containing greetings in 55 languages, sounds of Earth, and a diverse collection of music serve as a universal message in a bottle, a testament to our existence and our desire to connect with the cosmos. As they drift silently through interstellar space, the Voyagers carry our collective hopes and aspirations, a beacon of human achievement in the vast expanse of the universe. Yet, the journey is far from over. Both Voyagers continue to transmit data back to Earth, their signals growing fainter with each passing year. By 2025, their power sources will begin to dwindle, forcing NASA to prioritize which systems remain operational. Eventually, the Voyagers will fall silent, becoming ghosts in the interstellar void. But their legacy will endure, a testament to a moment in time when humanity reached for the stars and found its place among them. Their cosmic alignment, a once-in-a-lifetime opportunity, has forever changed our understanding of the universe and our role within it. Section 2. The Launch of a Legend. Voyager 2 launched on August 20th, 1977, a modest-looking spacecraft wrapped in gold-colored insulation and powered by plutonium heat. Its 3 radioisotope thermoelectric generators, RTGs, provided a steady source of energy, converting the heat from the decay of plutonium-238 into electricity. These RTGs were designed to last far beyond the spacecraft's initial mission parameters, ensuring Voyager 2 could continue transmitting data back to Earth, even as it ventured into the farthest reaches of the solar system. Its onboard computers, though rudimentary by today's standards, had less memory than a modern digital watch, yet it became one of the most accomplished explorers in human history. The spacecraft's Mag-11 magnetometer, designed to measure the intensity and direction of magnetic fields, weighed only 5.5 pounds, but proved instrumental in mapping the uncharted territories of the outer planets. The journey of Voyager 2 was not just a feat of engineering, but a testament to human ingenuity and perseverance. It survived Jupiter's radiation storms, which are so intense that they can deliver a lethal dose of radiation to an unshielded human in less than a day. These storms are generated by the planet's rapid rotation. Jupiter completes one rotation every 9.9 hours, and its powerful magnetic field, which is 20,000 times stronger than Earth's. Voyager 2's trajectory was meticulously calculated to navigate through these hazards, allowing it to capture unprecedented images of the Great Red Spot, a storm that has raged on Jupiter for at least 350 years. The spacecraft then navigated Saturn's rings, a delicate dance that required precision timing and maneuvering. Saturn's rings are composed of countless particles of ice and dust, ranging in size from microscopic grains to house-sized chunks. Voyager 2's cameras revealed intricate details of these rings, including the thin, braided F-ring and the complex interactions between the rings and Saturn's numerous moons. One of its most striking discoveries was the intricate hexagonal storm at Saturn's North Pole, a feature that remains one of the most enigmatic phenomena in the solar system. Voyager 2 became the first and only spacecraft to visit Uranus and Neptune, revealing worlds that were previously little more than distant blurry dots in telescopes. At Uranus, it discovered a planet tilted so dramatically on its axis, 98 degrees, that its seasons are unlike any other in the solar system. Its magnetic field is also wildly misaligned, tilted at 59 degrees relative to its axis of rotation, causing its auroras to appear offset from the poles. Voyager 2's flyby of Uranus also revealed a system of 10 new moons, including the 5 largest: Ariel, Umbriel, Titania, Oberon, and Miranda. Miranda, in particular, stunned scientists with its bizarre patchwork surface, a testament to a violent history of geological upheaval. At Neptune, Voyager 2 unveiled a world of extremes. The planet's Great Dark Spot, a storm system large enough to swallow Earth, was accompanied by fast-moving white clouds nicknamed scooters. Neptune's winds are the fastest in the solar system, reaching speeds of up to 1,100 miles per hour. The spacecraft also discovered 6 new moons orbiting Neptune, including the geologically active Triton. This moon's surface is one of the coldest in the solar system, with temperatures plunging to 309.235 Celsius, yet it hosts geysers that erupt plumes of nitrogen gas up to 5 miles high. These discoveries rewrote our understanding of the solar system, revealing a cosmos alive with violence and complexity. But the deeper Voyager 2 traveled, the stranger its observations became. Its plasma wave subsystem, PWS, designed to detect the faint electrical signals of plasma waves in space, picked up sounds that scientists described as eerie and otherworldly. These sounds, when converted into audible frequencies, ranged from whistles and chirps to haunting moans, providing a symphony of the cosmos that had never been heard before. As it crossed the heliopause, the boundary where the solar wind collides with the interstellar medium, it entered a region where the physics of the cosmos behaved in ways scientists had never anticipated. The heliopause is not a fixed boundary, but a dynamic interface, shifting in response to changes in the solar wind and interstellar conditions. Its exact location varies, but Voyager 2 crossed it at approximately 120 astronomical units, AU, from the Sun, where 1 AU is the distance between Earth and the Sun. And now, decades later, this same region has given us a transmission that defies all explanation. The signal detected by Voyager 2's onboard instruments is unlike anything previously recorded. It is not a simple radio wave or cosmic ray burst, but a complex pattern that has resisted all attempts at decryption. Scientists have speculated that it could be a natural phenomenon, perhaps a previously unknown interaction between the solar wind and interstellar particles. Others have ventured more radical theories, suggesting it could be a message from an extraterrestrial civilization. However, without additional data, the signal remains an enigma, a whisper from the edge of interstellar space that challenges our understanding of the universe. Observation: the signal's frequency and modulation patterns are unlike any known natural or artificial source. Its persistence over time suggests it is not a random event, but a structured transmission. Interpretation: the signal could represent a new class of astrophysical phenomena or, more speculatively, a form of communication from an intelligent source. Further analysis is required to rule out instrumental artifacts or terrestrial interference. Speculation: if the signal is indeed of extraterrestrial origin, it raises profound questions about the nature of life in the universe and our place within it. However, until more evidence is gathered, such interpretations remain purely hypothetical. As Voyager 2 continues its journey into the unknown, it carries with it the hopes and dreams of humanity, a symbol of our relentless quest for knowledge and understanding. Its golden record, a time capsule of Earth's cultures and achievements, serves as a message in a bottle, a testament to our existence for any civilization that might one day discover it. And as we await further transmissions from the edge of interstellar space, we are reminded of the vastness of the cosmos and the endless possibilities it holds. Section 3. The heliopause, where the Sun's influence ends. The heliopause is the outermost boundary of the Sun's influence, the place where the solar wind, a constant stream of charged particles traveling at speeds up to 800 kilometers per second, finally gives way to the interstellar medium. This region, known as the Helios heath, is a turbulent zone where the solar wind slows dramatically and interacts with the interstellar medium, creating a dynamic and unpredictable environment. Models predicted a gradual transition, a soft fade, but Voyager 2 found something far more chaotic. Pressure waves slammed into the spacecraft, charged particles surged unpredictably, and magnetic fields twisted in violent, unexpected directions. The density of plasma jumped by a factor of 40, a surge that scientists initially struggled to believe. For the first time in history, humanity tasted the raw, unfiltered environment of interstellar space, a realm shaped not by our star, but by the forces of the cosmos beyond. The heliopause is not a static boundary, but a dynamic interface, fluctuating in response to the ever-changing conditions of the solar wind and the interstellar medium. Its shape is irregular, distorted by the motion of the Sun through the galaxy and the varying pressures of the interstellar environment. This boundary stretches outward in the direction of the Sun's motion, forming a comet-like tail that extends far beyond the heliosphere. The heliopause is estimated to be approximately 123 astronomical units, AU, from the Sun, though its exact location varies depending on solar activity and the local conditions of the interstellar medium. Recent studies suggest that this tail, known as the heliotail, could extend up to $1,000 AU, a staggering distance that underscores the vast scale of the solar system's interaction with the interstellar medium. As the Sun moves through the Milky Way at a speed of about 230 kilometers per second, it drags the heliosphere with it, creating a bow shock-like structure ahead of the heliopause, akin to the wave formed at the bow of a ship moving through water. Voyager 1, the first spacecraft to cross the heliopause, did so in August 2012 at a distance of about 121 AU from the Sun. Its instruments detected a sharp increase in galactic cosmic rays, high-energy particles that originate from outside the solar system. These rays, which are mostly deflected by the solar wind within the heliosphere, provided a clear indication that the spacecraft had entered interstellar space. The plasma density around Voyager 1 also increased dramatically, confirming the transition. However, the heliopause did not remain unchanged. When Voyager 2 crossed the boundary in November 2018 at a distance of 119 AU, the conditions were markedly different. The boundary was thinner, sharper, more active, almost as if something had disturbed it, shifted it, or manipulated it since the first probe's encounter. This asymmetry didn't make sense, and it planted the first seeds of doubt in the minds of NASA's mission team. The discrepancy between the two crossings has led scientists to question whether the heliopause is more complex than previously thought, with local variations in the interstellar medium playing a significant role in shaping its structure. Observation. The heliopause's variability suggests that it is not a fixed boundary, but a dynamic region influenced by both solar and interstellar forces. The differences observed by Voyager 1 and Voyager 2 highlight the complexity of this interaction. The solar wind's pressure can fluctuate significantly over time, especially during periods of high solar activity, such as solar maximum, when the sun's magnetic field is at its strongest and most chaotic. These fluctuations can cause the heliopause to expand and contract, altering its shape and behavior. Similarly, variations in the interstellar medium, such as changes in the density or velocity of interstellar gas, can affect the heliopause's structure. For example, the passage of the solar system through the local interstellar cloud, a region of denser interstellar gas, may have influenced the heliopause's behavior over the past few thousand years. Interpretation. The heliopause's behavior may also reflect the influence of the interstellar magnetic field, which is thought to be oriented differently from the sun's magnetic field. This misalignment could create instabilities at the heliopause, leading to the chaotic conditions observed by the Voyager spacecraft. Additionally, the interaction between the solar wind and the interstellar medium may generate turbulence, further complicating the boundary's dynamics. The heliopause, therefore, is not just a theoretical concept, but a real, physical barrier with profound implications for our understanding of the solar system's edge. Scientists now believe that the heliopause may also emit low-frequency radio waves, known as heliospheric radio emissions, which could provide additional clues about its behavior and structure. Speculation. Some scientists have hypothesized that the heliopause's variability could be influenced by external forces beyond the interstellar medium. For example, the gravitational influence of nearby stars or the passage of the solar system through different regions of the galaxy could subtly affect the heliopause's shape and behavior. While these ideas remain speculative, they underscore the complexity of the heliopause and the challenges of studying it. As the Voyager spacecraft continue their journey into interstellar space, they will provide new insights into this enigmatic boundary, helping us better understand the true extent of the sun's influence and the nature of the cosmos beyond. Some researchers have even proposed that future missions could involve deploying a fleet of small, low-cost spacecraft to study the heliopause from multiple angles, providing a more comprehensive understanding of its behavior. The heliopause also serves as a protective shield for the solar system, deflecting a significant portion of the high-energy cosmic rays that would otherwise bombard the Earth and other planets. These rays, which include protons, electrons, and heavier nuclei, can damage DNA, disrupt electronic systems, and pose a significant hazard to astronauts on long-duration missions. By studying the heliopause, scientists hope to better understand how it shields us from these dangers and how its behavior might change in the future. This knowledge could inform the design of future spacecraft and habitats, ensuring their safety in the harsh environment of space. For instance, understanding the heliopause's role in deflecting cosmic rays could help engineers develop more effective radiation shielding for future Mars missions or lunar habitats. In addition to its scientific significance, the heliopause holds a deep symbolic meaning. It represents the edge of humanity's influence, the boundary beyond which our star's protective embrace no longer reaches. Crossing this threshold marks a milestone in our exploration of the cosmos, a testament to our curiosity and ingenuity. The Voyager spacecraft, now far beyond the heliopause, carry with them the hopes and aspirations of humanity, serving as our emissaries to the stars. Their journey reminds us that our understanding of the universe is still in its infancy, and that there is much more to discover in the vast, unexplored realms of interstellar space. As the Voyager spacecraft drift into the unknown, they carry with them the Golden Record, a time capsule containing sounds and images from Earth, intended to communicate our story to any extraterrestrial civilization that might one day encounter these interstellar travelers. Section 4. The Interstellar Hum. Beyond the heliopause, Voyager 2 entered a realm of pure interstellar plasma, material that hasn't touched the sun in billions of years. This region, known as the interstellar medium, is a vast expanse of gas and dust stretching between star systems, averaging just 1 atom per cubic centimeter. NASA assumed it would be quiet out there, a kind of cosmic emptiness, devoid of the chaotic solar winds and magnetic fields that dominate the heliosphere. But that assumption shattered almost immediately. Voyager began detecting a hum, a constant low-frequency vibration echoing through the plasma. This faint, persistent signal, measured at a steady 3 kHz, was a revelation, a whisper from the void that hinted at unseen forces shaping the galaxy. The hum wasn't the chaotic, unpredictable environment scientists expected. It was structured, layered, almost organized, like something humming beneath the cosmic floorboards. The Voyager team likened it to the background noise of a distant city heard from a hilltop at night, indistinct yet unmistakably patterned. This discovery challenged existing models of interstellar space, which had long been described as a silent, featureless expanse. Instead, the hum suggested a dynamic, responsive medium filled with subtle currents and interactions that astronomers were only beginning to understand. Over the years, the hum's frequency drifted, changed, and responded to unknown fluctuations. Between 2013 and 2023, Voyager's plasma wave instrument recorded over 300 variations in the hum's pitch and intensity. Some shifts were gradual, spanning months, while others occurred in sudden bursts, lasting mere hours. These fluctuations seemed to correlate with changes in the density of the interstellar medium, but the exact mechanisms remained elusive. And now, inside the latest transmission, that hum has shifted dramatically, as if something in the interstellar medium has awakened, moved, or responded to Voyager's presence. The tone deepened, dropping to 2.5 kV, and the amplitude surged by 20%, a change so abrupt it initially puzzled the team at NASA's Jet Propulsion Laboratory. What could be causing this structured, rhythmic pulse? Theories abound, but few answers are concrete. One hypothesis points to distant supernova remnants, their shock waves rippling through the interstellar medium like cosmic tidal forces. Another suggests the hum is the collective resonance of countless stars and black holes, their gravitational interactions creating a symphony of vibrations that echo through space. A more speculative idea proposes that the hum is a byproduct of dark matter interactions, a faint electromagnetic signature of particles that remain undetectable by other means. Each theory offers a glimpse into the vast hidden processes shaping the galaxy, but all lack definitive proof. And why does it seem to be growing stronger? This question has sparked intense debate among astrophysicists. Some argue that Voyager is simply moving into denser regions of the interstellar medium, where the hum naturally amplifies. Others suggest that the hum's increasing intensity reflects a broader change in the galaxy itself, perhaps the aftermath of a distant stellar event, or the ebb and flow of cosmic tides. A more unsettling possibility is that the hum is not a passive phenomenon but a response to Voyager's presence, a kind of cosmic awareness stirred by the probe's journey. Observation. The hum's recent shift coincided with a sharp increase in cosmic ray activity detected by Voyager's instruments. These high-energy particles, accelerated by distant supernova and other violent events, may play a role in modulating the hum's frequency and intensity. Scientists are now analyzing whether this surge in cosmic rays is a localized event or part of a larger galactic cycle. Interpretation. If the hum is indeed influenced by cosmic rays, it could serve as a natural barometer for tracking the ebb and flow of these particles across the galaxy. This would make Voyager not just a messenger from Earth, but a living sensor, providing real-time data on the dynamics of the interstellar medium. Such insights could revolutionize our understanding of how energy and matter flow through the cosmos. Speculation. What if the hum is not unique to our region of space? Could it be a universal phenomenon, a background noise that permeates every corner of the galaxy? If so, it would imply that the interstellar medium is far more interconnected than we ever imagined, with forces and signals propagating across light years like ripples in a cosmic pond. This would challenge our understanding of space as an empty void, and instead paint it as a vast, resonant chamber, alive with unseen interactions. As Voyager continues its journey, the hum grows louder, more insistent, a soundtrack to the probe's lonely voyage through the stars. It is a reminder that even in the emptiest regions of the universe, there is structure, rhythm, and perhaps even meaning. The hum is a call from the cosmos, a signal waiting to be deciphered, and it beckons us to listen, to question, and to venture further into the unknown. Section 5. The 7-month silence. In 2020, communication with Voyager 2 was lost for 7 months. NASA blamed it on a misalignment of the Canberra dish in Australia, the only antenna capable of contacting the probe. But that explanation never fully satisfied the mission specialists. The Canberra Deep Space Communication Complex, nestled in the quiet of the Tidbinbilla Valley, is a marvel of engineering. Its 70-meter dish, a lifeline to the farthest reaches of human exploration. For 7 months, this lifeline went silent, leaving Voyager 2, a spacecraft that had faithfully transmitted data for over 4 decades, isolated in the void. The official report cited a 2-degree alignment error in the dish's azimuth track, a minor misalignment that nonetheless severed the tenuous thread connecting Earth to its farthest emissary. Yet some engineers whispered doubts, questioning how such a small error could have caused such a prolonged blackout. During those 7 months, Voyager 2 drifted silently through interstellar space, over 12 billion miles from home. The spacecraft, launched in 1977, had long since left the realm of the planets, crossing the heliopause in 2018 to enter the unexplored territory between stars. Here, the sun's influence wanes, and the interstellar medium, a diffuse soup of particles and magnetic fields, holds sway. Voyager 2, designed to study the outer planets, had become humanity's first interstellar explorer, a lonely vanguard in the endless night. Yet for 7 months, its voice was silent, its data unseen, as it continued its journey at over 34,000 miles per hour. When contact was finally restored, the data Voyager 2 sent back was different. Magnetic field readings were altered, plasma density had shifted unexpectedly, and even more bizarrely, the spacecraft had reoriented itself slightly, correcting its antenna without NASA's commands. The magnetic field readings, normally steady, showed strange fluctuations, spikes in intensity that defied easy explanation. Plasma density, a measure of the ionized gas that permeates interstellar space, had increased by as much as 15% in some instances, a change that should have been accompanied by corresponding variations in other data, yet wasn't. And the spacecraft's orientation, that was the most unsettling. Voyager 2's attitude control system, responsible for keeping its antenna pointed at Earth, had been largely dormant for years, its thrusters firing only occasionally to make minor corrections. Yet, during the blackout, the spacecraft had made adjustments, small but precise, realigning itself to within 0.05 degrees of optimal orientation. Voyager 2 shouldn't be able to autonomously correct its orientation anymore. The systems designed for that have been degrading for decades. The spacecraft's power output, supplied by 3 radioisotope thermoelectric generators, had declined to about 60% of its original capacity. Heaters and other non-essential systems had been shut down to conserve energy, leaving Voyager 2 running on the barest of margins. Yet somehow, during the blackout, Voyager held its course and aimed back at Earth with almost perfect precision. The onboard computer, a relic of 1970s technology with less processing power than a modern smartwatch, should not have been capable of such finesse. But the data was clear. Voyager 2 had adjusted its trajectory silently and autonomously in the cold darkness of interstellar space. And, shortly after that restoration, the anomalies in the interstellar hum became more pronounced. That 7-month gap now looks less like a communication failure and more like something interfered, interrupted, or interacted with the probe. The interstellar hum, a faint but persistent radio emission detected by Voyager 2, had always been a mystery. Some theories suggested it was the background noise of the universe itself, the echo of cosmic inflation, or the faint whisper of dark matter. But after the blackout, the hum changed. Its frequency shifted subtly. Oscillations that had once been steady now fluctuated in erratic patterns. Most intriguingly, the hum seemed to respond to Voyager 2's position, growing louder as the spacecraft adjusted its orientation, as if the probe were tuning into an unknown signal. Observation. The changes in Voyager 2's data are not easily explained by known phenomena. The magnetic field fluctuations, plasma density shifts, and the spacecraft's autonomous reorientation all point to an external influence. Yet, no known celestial object or interstellar event aligns with the timeline or characteristics of these anomalies. The possibility that Voyager 2 encountered something unprecedented, a new type of cosmic phenomenon, an uncharted interstellar feature, or even an artificial structure cannot be dismissed. Interpretation. If Voyager 2 did encounter something, it raises profound questions about the nature of interstellar space and humanity's understanding of the universe. The spacecraft's ability to adjust its trajectory autonomously suggests a level of intelligence or design, whether human, alien, or an as-yet unrecognized natural process. The changes in the interstellar hum further imply that Voyager 2 may have interacted with a phenomenon capable of responding to its presence, akin to a cosmic lighthouse or beacon. Speculation. Could Voyager 2 have encountered an artificial structure, a relic of an ancient civilization, or a natural formation with properties unlike anything seen before? The data hints at a deliberate interaction, as if the probe were guided or influenced by an external intelligence. Alternatively, the anomalies could represent a new class of cosmic phenomena, one that challenges existing models of astrophysics and cosmology. Whatever the truth, Voyager 2's 7-month silence may mark the beginning of a new era in humanity's exploration of the cosmos, one defined not by the void of space, but by the mysteries hidden within it. Section 6. The Invisible Wake. When Voyager 2 returned to full communication, scientists began noticing something their equations couldn't account for. The magnetic field lines around the spacecraft weren't behaving the way interstellar medium models predicted. Instead of flowing smoothly, they bent gradually and then sharply, almost as if the craft were moving through an invisible wake. One engineer described it as though Voyager 2 had passed through the exhaust of something enormous, a sensation akin to the gentle push of a tide against a drifting ship. The phenomenon was subtle but undeniable, a faint ripple in the cosmic fabric that shouldn't have been there. The data was so anomalous that it initially puzzled the team, who spent weeks rechecking the instruments and recalibrating the sensors to ensure it wasn't a malfunction. In the dimly lit mission control room, the hum of computers was occasionally broken by the murmurs of scientists poring over printouts, their faces illuminated by the glow of screens displaying inexplicable patterns. The distortions in the magnetic field were unlike anything ever recorded. They stretched across thousands of kilometers, dwarfing the scale of any known natural phenomena in the interstellar medium. To put it into perspective, the Earth's magnetic field extends roughly 60,000 kilometers into space, but the wake detected by Voyager 2 spanned distances that were orders of magnitude greater. The patterns were consistent, repeating every few hours as Voyager 2 continued its journey, suggesting a structured, coherent source. If this were truly the wake of an object, its size would need to be unimaginably vast, potentially spanning millions of kilometers, a scale so immense it would take light itself minutes to traverse its length. The team ran simulations to model what kind of object could create such a disturbance, but every hypothesis seemed to defy conventional physics. In one simulation, the object's projected mass was so great that it would have warped space-time itself, yet no gravitational anomalies were detected. Natural magnetic waves don't create that pattern. Plasma turbulence doesn't create that pattern, but an object moving through space does. The distortions were too symmetrical, too clean, too smooth, and they lasted too long to be random. They persisted for nearly 3 weeks before gradually fading, as if Voyager 2 had finally moved beyond the edge of whatever had caused them. The team calculated that if the wake was indeed the result of an object, it would need to be traveling at a significant fraction of the speed of light to create such a lasting disturbance. To produce such an effect without detectable radiation, the object would have to be moving at least 10% the speed of light, or roughly 30,000 kilometers per second, a velocity that would allow it to cross the distance from Earth to the Moon in less than 2 seconds. NASA avoided that language publicly, but internally, the team acknowledged the possibility that Voyager 2 may have crossed paths with something moving through interstellar space, something capable of disturbing magnetic lines at massive scales. The implications were staggering. If this was an object, a structure, a vessel, or something entirely unknown, it challenged humanity's understanding of what was possible in the universe. The team began quietly referring to the event as the Invisible Wake, a name that stuck in the classified reports and internal memos. In one memo, a senior researcher wrote, "We are witnessing something that should not exist, yet the data is irrefutable. This is either the greatest discovery of our time or a puzzle we may never solve." One of the most intriguing observations was the lack of electromagnetic interference. Whatever had caused the wake did not emit any detectable radiation or energy signatures. This suggested that the object, if it existed, was either incredibly advanced or composed of materials that interacted with space in ways far beyond human technology. The team speculated that such an object could be using propulsion methods that were completely silent, leaving only the faint magnetic distortion as evidence of its passage. Some theorized that it might employ a form of propulsion that manipulated space-time itself, bending the fabric of the universe to move without emitting energy. This idea, though purely speculative, was not entirely without precedent. Einstein's general theory of relativity had long suggested that massive objects could warp space-time, and some theoretical models proposed that such warping could be harnessed for travel. The team also noted that the wake's symmetry suggested intentionality. It was as if the object had been designed to minimize its impact on the interstellar medium, leaving behind only the faintest trace. This raised the question of whether the wake was the result of natural evolution or engineering. If the latter, it implied a level of technological sophistication that dwarfed anything humanity had ever imagined. The team debated whether to include this speculation in their reports, but ultimately decided to keep it confidential, fearing the potential backlash from the scientific community. In hushed conversations over coffee in the break room, some jokingly referred to it as the thing that shouldn't be, a phrase that carried both awe and unease. Despite the caution, the discovery of the invisible wake sparked quiet excitement within the team. It was a reminder that the universe was still full of mysteries, that even after decades of exploration, there were phenomena that defied explanation. Voyager 2, now billions of kilometers from Earth, had once again proven its value as a pioneer, pushing the boundaries of human understanding. The team continued to monitor the data, hoping for more clues, but the wake never reappeared. It remained a singular, enigmatic event, a whisper from the cosmos, heard once and then lost to the void. Some team members couldn't help but feel a sense of longing, as if they had glimpsed something profound but fleeting, like a distant star that blinks out of existence before its light can fully reach us. Observation. The magnetic field distortions were consistent with the wake of an object moving through interstellar space at relativistic speeds. Interpretation. The symmetry and coherence of the wake suggest an intentional design, implying the possibility of an engineered object rather than a natural phenomenon. Speculation. If the wake was indeed caused by an object, its size, speed, and technological sophistication would far exceed anything within human capability or understanding. Its silent passage through the cosmos could represent a level of advancement so far beyond our own that it challenges the very framework of our scientific inquiry. Section 7. The Structured Oscillations. Interstellar plasma is supposed to behave like a chaotic ocean, unpredictable, stormy, constantly changing. But the plasma oscillations Voyager 2 began detecting were anything but random. They surged in perfect intervals, repeating with such precision that they resembled code more than turbulence. These oscillations were not subtle. They registered as sharp spikes on the probe's plasma wave instrument, a device designed to measure the density and activity of charged particles in space. On average, these oscillations occurred every 3.2 seconds, a rhythm so consistent it defied natural explanation. The data streams showed peaks that towered above the background noise, their symmetry almost mathematical in nature, as if an unseen hand were tuning the cosmos itself. The probe's plasma wave instrument, developed by researchers at the University of Iowa, had already revolutionized our understanding of solar system dynamics. It detected the whistling of auroral kilometric radiation at Neptune and the crackling of Jupiter's intense radiation belts. But nothing compared to this. The oscillations stood out starkly against the quiet hum of interstellar space, where particle densities are a fraction of those found near the planets. At times, the oscillations spiked with such intensity that they briefly overwhelmed the instrument's sensors, forcing automatic gain adjustments to prevent saturation. This wasn't mere noise. It was a signal, structured and insistent, demanding attention. Sometimes the oscillations synchronized with Voyager's engineering transmissions, aligning perfectly with the timing of routine telemetry signals sent back to Earth. Other times they changed frequency in response to the probe's routine pings, as though the medium itself were responding to the presence of the spacecraft. That should be impossible. Plasma doesn't respond to spacecraft communications like that. It is a diffuse ionized gas, governed by the laws of electromagnetism and fluid dynamics, not by the whims of human-made signals. But something did in the latest transmission. The oscillations not only returned, they evolved, forming complex harmonics not seen in any previous dataset. At least one of these harmonics matches the rhythm Voyager 2 has been transmitting for decades, almost as if something had learned to echo the probe's heartbeat back at us. The implications of these patterns are staggering. Voyager 2, launched in 1977, has been traveling through the cosmos for over 45 years, its signals growing fainter with every passing light year. By now, the probe is over 125 astronomical units from Earth, far beyond the influence of the Sun's magnetic field. Yet, in the void of interstellar space, these oscillations emerged, as precise as a metronome, as deliberate as a coded message. Scientists have long studied plasma waves in the solar system, from the solar wind that buffets Earth's magnetosphere to the auroras that dance in the polar skies. But these interstellar oscillations are different. They are structured, purposeful, and seemingly interactive, defying every model of plasma behavior developed over the past century. Observation: the oscillations appear to cluster in specific frequency bands, particularly in the range of 2.8 to 3.5 kHz. This range corresponds to the natural resonance frequency of the plasma wave instrument's antenna, a detail that has led some researchers to speculate about the possibility of instrumental artifacts. However, the patterns persist even when the instrument is recalibrated, and they exhibit variations that cannot be explained by hardware alone. The oscillations also display a curious memory effect, where certain frequencies repeat hours or even days after their initial detection, as though the plasma itself were retaining information over time. One particularly striking observation occurred on May 12, 2021, when the oscillations abruptly shifted to a higher frequency band for exactly 17 minutes before returning to their previous state. This event coincided with a routine diagnostic check of Voyager's communications system, during which the probe transmitted a series of test pulses. The timing was too precise to be coincidental, yet no known physical process could explain such a rapid and coordinated response. The event left researchers both exhilarated and unnerved, as it suggested not just interaction but anticipation, as if the oscillations were reacting to something they had learned from previous transmissions. Interpretation: one hypothesis suggests that the oscillations are the result of an unknown interaction between the solar wind and the interstellar medium. As Voyager 2 transitions from the heliosphere, the bubble of solar influence, into the true interstellar space beyond, it may be encountering phenomena never before observed. The solar wind, a stream of charged particles ejected by the Sun, collides with the interstellar medium at the heliopause, creating a complex boundary layer where energy and matter are exchanged. This interaction could, in theory, generate structured oscillations under certain conditions. However, this explanation struggles to account for the precise timing and apparent responsiveness of the oscillations to Voyager's signals. Another interpretation points to the role of magnetic fields in shaping plasma behavior. The interstellar medium is threaded with faint magnetic fields, remnants of ancient supernova and galactic dynamics. These fields could, in theory, trap and modulate plasma waves, creating the structured patterns observed by Voyager. However, the magnetic fields in interstellar space are extraordinarily weak, measuring just 0.3 nanoteslas, barely enough to influence charged particles on such a grand scale. Moreover, the oscillations seem to defy the slow, diffusive nature of magnetic interactions, responding instead with the immediacy of a conscious entity. Speculation. A more radical theory proposes that the oscillations are not natural at all, but rather the product of an intelligence, perhaps even a form of communication. The idea is not without precedent. In 1974, astronomer Frank Drake sent the Arecibo message, a radio transmission containing encoded information about humanity, toward the globular star cluster M13. The message was a deliberate attempt to communicate with extraterrestrial civilizations, should they exist. If an advanced civilization were capable of manipulating plasma waves, they might use such a medium to transmit information or even mimic the signals of a passing spacecraft. While this explanation is highly speculative, it cannot be entirely dismissed, given the unprecedented nature of the oscillations. Some researchers have even begun to explore the possibility that the oscillations could be a form of non-human intelligence. In 2022, a team at the SETI Institute ran the data through algorithms designed to detect patterns in extraterrestrial signals. The results were inconclusive but intriguing. The oscillations exhibited statistical properties more akin to language than to random noise. Of course, this does not prove intelligence, but it does raise the question of whether we are witnessing a phenomenon beyond our current understanding of physics. What could be causing these structured, rhythmic patterns? And why do they seem to be responding to the probe? These questions haunt the scientists who analyze Voyager's data, pushing the boundaries of their understanding. The oscillations challenge not only their assumptions about plasma physics, but also their conception of what is possible in the vast, unexplored reaches of interstellar space. Voyager 2 continues its journey, its signals faint but steady, a beacon in the cosmic sea. And with each transmission, the mystery of the structured oscillations deepens, a riddle written in the language of the stars. Section 8. The Power Surge. Voyager 2 is powered by radioactive decay, a steady, predictable process that decreases a little every year. Its 3 radioisotope thermoelectric generators, RTGs, each containing 24 pressed plutonium-238 oxide spheres, have been slowly losing power since their activation in the 1970s. By 2023, the power output had dropped to approximately 345 watts, a mere 64% of the 537 watts available at launch. This relentless decline is a known quantity, a quiet countdown to the day when the spacecraft will no longer have enough power to operate its scientific instruments or transmit data back to Earth. Yet, in the months leading up to the mysterious transmission, something unexpected happened. Engineers monitoring the probe's vital signs noticed a temporary increase in transmission stability and power consistency, an event as inexplicable as it was fleeting. For a period of roughly 12 days, Voyager 2 seemed to defy its own inevitable decline. Telemetry data showed a 3.2% increase in power stability, a marginal but measurable improvement in the consistency of the spacecraft's electrical systems. The signal strength, which had been slowly degrading over the decades, suddenly displayed a brief but unmistakable surge. Ground stations on Earth, accustomed to compensating for the probe's fading voice, recorded a temporary improvement in signal-to-noise ratio, as if the spacecraft had found a second wind. This anomaly was not confined to a single system. It was observed across multiple subsystems, from the Attitude and Articulation Control System, AACS, to the Flight Data Subsystem, FDS. Yet, as quickly as it began, the surge subsided, and Voyager 2 resumed its steady decline, leaving engineers to question whether they had witnessed a glitch or a genuine phenomenon. The RTGs themselves could not account for the surge. Their design, based on the predictable decay of plutonium-238, does not allow for fluctuations in power output. Each RTG contains a thermocouple assembly that converts the heat generated by radioactive decay into electricity, a process that is immune to external influence. The only variables that could theoretically affect power output, such as temperature or degradation of the thermocouples, had remained constant throughout the anomaly. Moreover, the surge was not accompanied by any corresponding increase in the RTG's thermal output, ruling out the possibility of a sudden spike in radioactive decay. Whatever had happened, it was not a result of the spacecraft's power source. Some engineers initially suggested that Voyager 2 had passed into a region of reduced cosmic ray interference. Cosmic rays, high-energy particles that permeate the universe, can degrade electronic systems over time, causing memory errors and system instability. However, this hypothesis was quickly discounted. The spacecraft's Cosmic Ray Subsystem, CRS, one of its scientific instruments, detected no significant change in cosmic ray flux during the surge. In fact, the CRS data showed a slight increase in cosmic ray activity, the opposite of what would be expected if reduced interference were the cause. Others proposed a temporary alignment of magnetic fields, perhaps amplifying the spacecraft's ability to transmit data. Voyager 2 is equipped with a magnetometer, part of its plasma wave subsystem, PWS, which measures the strength and direction of magnetic fields in interstellar space. However, the PWS data revealed no unusual magnetic activity during the surge. The heliopause, the boundary where the solar wind's influence wanes and interstellar magnetic fields take over, had long since been crossed, and the magnetic environment had remained stable for years. If anything, the magnetometer detected a slight decrease in magnetic field strength during the anomaly, further complicating the search for an explanation. The timing of the surge, however, was impossible to ignore. It coincided almost perfectly with the transmission of the structured oscillations, the enigmatic patterns that had sparked so much curiosity and debate. The power surge began approximately 48 hours before the first detection of the unusual signal and ended roughly 24 hours after its transmission. This temporal alignment was too precise to be mere coincidence. Something, whether environmental or external, had stabilized Voyager 2 just as it sent the most mysterious signal of its entire mission. Observation. The power surge was not an isolated event. It was part of a larger sequence that included the structured oscillations and the anomalous transmission. The fact that these phenomena were observed across multiple subsystems suggests a common cause, though the nature of that cause remains elusive. Interpretation. If the power surge and the transmission are indeed linked, it raises questions about the origin of the signal. Did Voyager 2 encounter something in interstellar space that temporarily enhanced its systems, or was the surge a byproduct of whatever process generated the signal? The precise alignment of these events suggests a deliberate or directed influence, though this remains purely speculative. Speculation. Could the power surge have been a side effect of Voyager 2 interacting with an unknown phenomenon or entity? While this idea ventures into the realm of the extraordinary, the absence of a conventional explanation leaves room for more unorthodox hypotheses. If the surge was not caused by the spacecraft itself or its environment, it implies an external influence, one that remains unexplained. In the quiet halls of Mission Control, where the walls are lined with charts and graphs detailing every fluctuation in Voyager's vital signs, the power surge was more than just a blip on a screen. It was a reminder that even after decades of exploration, the universe still holds surprises. As engineers pored over the data, searching for patterns or correlations that might explain the anomaly, they couldn't shake the feeling that they were looking at the edge of something larger, something that defied easy categorization. The power surge, like the transmission itself, was a puzzle piece that refused to fit neatly into the established picture of the cosmos. And yet, in its defiance, it offered a tantalizing glimpse of the unknown. A reminder that the universe is not a closed book, but an ever-expanding frontier. Section 9. The Unknown Signal. When the Deep Space Network finally received the first packets of Voyager 2's new transmission, the engineers expected the usual weak carrier tones, plasma data, engineering logs, and temperature readings. The signal had traveled over 12 billion miles, a journey that took more than 16 hours to reach Earth at the speed of light. But this time, the carrier tone wasn't weak. It was too stable, too sharp, too controlled, almost as if something had helped reinforce the signal. The tone oscillated at a frequency of 2.3 GHz, a bandwidth Voyager had never used before. Then the data stream began to show anomalies, repeating sequences embedded inside noise, timing intervals that didn't match the spacecraft's standard telemetry cycle, and frequency modulations that no one had ever seen from Voyager. The engineers huddled in the dimly lit control room at the Jet Propulsion Laboratory, their faces illuminated by the glow of screens displaying waveforms and spectrograms. The smell of stale coffee and the hum of ventilation systems filled the air. These anomalies weren't glitches, they were intentional patterns. As the stream continued, several pulses arrived at perfectly timed intervals. Intervals that matched neither engineering routines nor scientific sampling. Something was modulating the transmission. The engineers calculated the intervals down to the millisecond, finding a recurring pattern every 1.728 seconds, a number that held no significance in Voyager's programming. And then NASA realized the most unsettling part. Voyager 2 wasn't the source of every pulse. Some of them came from outside the spacecraft, from somewhere near it. The team quickly ruled out solar interference or cosmic ray bursts, as the pulses were too precise, too structured. They analyzed the Doppler shift of the incoming signals, confirming that the external pulses originated from a source moving independently of Voyager. The unknown signal was not just a random occurrence, it was a deliberate intrusion. The engineers began to speculate about the nature of this unknown source. Could it be another spacecraft? Unlikely, as no human-made object had ever ventured that far into interstellar space. The closest known object was the Pioneer 10 probe, which had gone silent in 2003 and was millions of miles away from Voyager's trajectory. Could it be a natural phenomenon, equally improbable given the mathematical precision of the pulses? Natural phenomena like pulsars or magnetars produced regular signals, but nothing this controlled or nuanced. Observation: the unknown signal's frequency modulation showed a distinct pattern, repeating every 36 cycles. This pattern did not correlate with any known astrophysical phenomenon or spacecraft malfunction. The signal's strength varied, suggesting it was being actively adjusted to maintain clarity over vast distances. The variations in amplitude seemed to compensate for the Doppler effect, ensuring the signal remained intelligible despite the relative motion of Voyager and the unknown source. Interpretation: the signal's characteristics pointed to an intelligent origin. The timing intervals, frequency modulation, and stability of the carrier tone all indicated a level of control that surpassed any natural or accidental explanation. The team began to consider the possibility of an extraterrestrial source, though they refrained from making any official statements. The implications were too staggering, too fraught with uncertainty. If this was a form of communication, it meant that humanity was not alone in the universe. If it was something else, a probe, a warning, or even a form of surveillance, it raised even more unsettling questions. The team debated whether to alert higher authorities within NASA or keep the findings confidential until more data could be gathered. Speculation: if the signal was indeed extraterrestrial, it raised profound questions. Was it a form of communication, a probe, or perhaps a warning? The engineers debated whether to respond, but the risk of unintended consequences was too great. Instead, they focused on gathering as much data as possible, hoping to decode the signal's underlying message. They considered the possibility that the signal was not meant for Voyager at all, but was simply intercepted by the spacecraft's sensors. If that were the case, the signal could be part of a much larger conversation occurring in the depths of space, one that humanity had only begun to eavesdrop on. The control room fell silent as the team watched the real-time spectrogram flicker with new pulses. Each pulse was a mystery, a fragment of a larger puzzle that seemed to defy human understanding. The unknown signal continued for hours, its patterns growing more complex with each passing minute. The engineers recorded every detail, their faces a mix of awe and unease. They were witnessing something unprecedented, something that challenged the very foundations of their understanding of the universe. The spectrogram displayed waves of light and dark, like an alien language written in lines and curves. The engineers leaned closer, their eyes scanning for any familiar pattern, any clue that might unlock the signal's meaning. As the signal began to fade, the engineers realized they had captured a moment that could redefine humanity's place in the cosmos. The data was irrefutable. Voyager 2 had encountered something beyond human comprehension. The signal's final pulse arrived with a slight deviation in frequency, as if to leave a lasting impression. And then, as suddenly as it had appeared, the unknown signal vanished, leaving only the faint hum of Voyager's regular telemetry. The room remained quiet for a long moment before someone finally spoke. "What do we do now?" The question hung in the air, unanswered as the team stared at the now empty spectrogram. The unknown signal had changed everything, and yet nothing had changed at all. The universe remained as vast and unknowable as ever, but now it held a new mystery, one that would haunt the engineers for years to come. In the days that followed, the team replayed the recorded signal over and over, searching for patterns they might have missed. They brought in specialists from other fields, mathematicians, cryptographers, even linguists, to help decode the mysterious transmission. Yet, despite their best efforts, the signal remained stubbornly elusive. It was as if it had been designed to be understood only by those who already knew its language. The engineers began to wonder if the signal was not meant to be deciphered at all, but rather to serve as a test of humanity's curiosity, ingenuity, and willingness to confront the unknown. If that were true, then the signal's true message might lie not in its content, but in its very existence. A reminder that the universe is far stranger and more wondrous than we can ever hope to comprehend. Section 10. The intentional silences. Inside the transmission were gaps, intentional silences spaced too precisely to be random noise or malfunction. These silences acted like separators, dividing the pulses into clusters, almost like headers in a digital file. On a monitor in the Jet Propulsion Laboratory, the gaps appeared as flat lines interrupting the oscillating waves of the signal, stark and deliberate, like the pauses in a Morse code message. NASA analysts ran every compression algorithm they had, cross-referencing the timing structure with databases of known astrophysical phenomena, and the results were unequivocal. The silences resembled packet formatting, not natural plasma behavior or the erratic bursts of pulsars. The probability of such a structure occurring naturally was calculated to be less than 1 in a trillion, a statistical impossibility in the known universe. The silences were not just passive divisions, but active components of the transmission. They lasted exactly 1.7 seconds each, a duration that matched no known cosmic interval, not the rotation of a pulsar, not the orbit of a planet, not even the flicker of a distant star. Instead, they aligned with a timing sequence that felt almost artificial. Engineers compared the pattern to the telemetry systems of every spacecraft ever launched, and the match was unsettling. The gaps formed a repeating cycle every 3.2 minutes, the same cycle Voyager 2 uses when transmitting engineering logs. This was no coincidence. Whatever was out there, it understood Voyager's timing. It behaved as if it were mirroring the probe, speaking in the rhythm Voyager itself used, almost as if to say, "I see you." The implications were staggering. If the silences were intentional, they suggested not just intelligence, but an understanding of Voyager's design. This wasn't a random signal from a distant star. It was a response, a deliberate echo. Scientists now believe the silences aren't empty. They're encoded pauses, waiting spaces, perhaps even requests. But what, or who, is sending them? The question haunted the halls of NASA, whispered in meetings and shouted in late-night debates. Some theorized that the silences were placeholders, spaces for Voyager to insert its own data, like a cosmic handshake. Others speculated they were timed delays, allowing for the vast distances the signal had to travel, over 12 billion miles from the edge of the solar system. Observation. The precise timing of the silences suggests a deep understanding of Voyager's communication protocols. The signal doesn't just mimic the probe's timing, it adapts to it, as if the sender has studied the probe's behavior over time. This level of synchronization implies observation and perhaps something more. To test this theory, NASA engineers sent a series of controlled signals to Voyager, instructing it to alter its transmission cycle. The response was immediate and chilling. The unknown signal adjusted its own timing to match Voyager's new pattern, maintaining the 3.2-minute cycle despite the change. It was as if the sender was listening, watching, and adapting in real time. The engineers ran the test 3 more times, each time altering Voyager's timing in unpredictable ways. Each time the signal responded in kind, never missing a beat. The probability of this happening by chance was effectively zero. Interpretation. The silences are not passive, they are interactive. They suggest a sender capable of real-time communication despite the staggering distances involved. This challenges our understanding of cosmic communication, which typically involves delays measured in hours or days, not seconds. The signal's ability to adapt suggests a technology far beyond our own, or a presence much closer than we dare imagine. But what if the silences aren't just technical markers, but semantic ones? What if they're not just dividing data, but conveying meaning? Linguists and cryptographers were brought in to analyze the signal, treating it not as a mathematical puzzle, but as a language. They noted that the silences weren't uniform. Subtle variations in their duration suggested inflection, stress, or emphasis. One analyst compared them to the pauses in human speech, not just gaps between words, but meaningful silences that convey doubt, expectation, or urgency. Speculation. If the silences are part of a language, they might be the equivalent of punctuation, giving structure and meaning to the pulses. Or they might be the language itself, with the pulses serving as accent marks or tonal shifts. This would explain why traditional decryption methods have failed. We've been trying to decode the pulses when the silences are the true message. In the quiet rooms of NASA, the silences took on a new significance. They were no longer just gaps in a signal, but potential breakthroughs in our understanding of the universe. They hinted at an intelligence that didn't just observe but communicated, that didn't just mimic but adapted, that didn't just exist but reached out. And in those silences, a new question emerged. What if the signal isn't just a message, but an invitation? An invitation to speak, to listen, to understand. An invitation to break the silence of the cosmos and say, "We see you too." Section 11. The Doppler Shift. One of the first things NASA checks in any anomalous transmission is the Doppler shift, the slight change in frequency caused by movement. And when they ran that analysis, the truth hit them like a wall. Not only did some pulses come from outside the spacecraft, but they were moving smoothly, moving predictably, moving in ways that matched neither dust nor rocks nor plasma waves. Something with mass, significant mass, was repositioning in Voyager 2's vicinity. The Doppler shift measured was not the random fluctuation of space debris, but a deliberate, calculated trajectory. The shift was subtle but unmistakable. A deviation of approximately 0.03 Hz, consistent with an object altering its velocity in a controlled manner. The engineers at NASA likened it to the steady hum of a well-tuned engine, a quiet but unmistakable signature of intent. The team at NASA's Jet Propulsion Laboratory, JPL, pored over the data, their screens glowing with graphs and waveforms that told a story no one expected. The Doppler shift wasn't the chaotic signature of a rogue asteroid or the erratic dance of cosmic dust. It was precise, almost surgical, as if whatever was out there knew exactly what it was doing. The object, estimated to be at least the size of a small satellite, was not merely floating aimlessly in the void. It was executing controlled, deliberate adjustments, its trajectory bending in ways that defied natural explanation. Over the course of 72 hours, the object made at least 3 distinct course corrections, each one aligning perfectly with Voyager's path. The precision was staggering, with deviations as small as 0.05 degrees, far beyond what any known natural phenomenon could achieve. And at one point in the data stream, the Doppler shift changed rapidly, almost as if the object performed a maneuver. That maneuver coincided with a magnetic field distortion Voyager detected in the same minute. Something moved near the probe, and the probe recorded the wake of that movement. The magnetic field distortion was slight, but measurable, a ripple in the interplanetary medium that suggested a mass of at least 500 kilograms had altered its course. The timing was impeccable, the change in trajectory occurring within a window of just 3.2 seconds. It was as if the object had anticipated Voyager's path and adjusted its own to avoid detection, yet left behind a trace, a whisper in the cosmic noise. The distortion was subtle, but it was enough to disrupt the probe's magnetometer for exactly 17 milliseconds, a blink of an eye in cosmological terms, but a glaring anomaly in the otherwise steady stream of data. Observation. The Doppler shift data revealed a pattern that was neither random nor explainable by known celestial phenomena. The object's movement was not merely a straight-line trajectory, but involved subtle course corrections, suggesting the presence of a propulsion system or some form of controlled navigation. The magnetic field distortion, though small, was significant enough to rule out natural causes like solar wind fluctuations or plasma interactions. The object's trajectory seemed to mirror Voyager's own, maintaining a consistent distance of approximately 3,000 kilometers for over 12 hours before breaking away. This behavior was unlike anything the team had ever observed in decades of deep space exploration. Interpretation. The deliberate nature of the object's movement implied intelligence. It wasn't just moving, it was navigating, adjusting its path with a precision that suggested purpose. The maneuver detected by Voyager was not a one-off event, but part of a larger pattern, a dance of sorts, where the object seemed to be shadowing the probe without ever directly interfering with its systems. The fact that the Doppler shift and magnetic field distortion aligned so closely in time suggested a level of coordination that was beyond coincidence. The object's movements were so precise that some team members jokingly referred to it as the choreographer, though the humor did little to mask their growing unease. Speculation. If the object was indeed artificial, it raised questions about its origin and intent. Was it observing Voyager, studying it as a relic of human technology? Or was it something more sinister, a sentinel guarding the edges of our solar system? The possibility of an extraterrestrial intelligence monitoring our early forays into deep space was both exhilarating and unsettling. It implied that we were not alone in the cosmos, but it also hinted at a level of surveillance that challenged our understanding of space exploration and our place in the universe. The team couldn't help but wonder if this was the first evidence of what astronomers had long theorized, a galactic club of advanced civilizations silently observing younger species as they ventured into the stars. The team at JPL spent countless hours debating the implications of the Doppler shift data. They ran simulations recreating the object's trajectory in digital models, and each time the results were the same. The movement was intentional, purposeful, and beyond anything they had ever encountered. The object's presence was a riddle, a cosmic enigma that defied easy answers. It was a reminder that even in the vast, empty expanse of space, we are not the only ones exploring, not the only ones watching. In one particularly tense meeting, a senior engineer compared the object to a silent shepherd guiding Voyager through the void without ever revealing itself. The metaphor stuck, and for weeks, the team referred to the mysterious object as the shepherd in their internal reports. In the quiet hum of the JPL control room, the scientists stared at the data, their minds racing with possibilities. The Doppler shift had opened a door to a world beyond our own, a world where objects moved with purpose and intelligence. It was a world that challenged everything we knew, a world that beckoned us to explore further, to seek answers in the silent depths of space. And so, the team turned their eyes back to the stars, knowing that somewhere out there, something was watching back. The Doppler shift data remained classified for years, but its implications echoed through the halls of JPL, a silent testament to the mysteries that still lurk in the shadows of our solar system. Section 12. The Correlations. The deeper scientists analyzed the transmission, the more correlations they uncovered. Plasma oscillations matching Voyager's telemetry patterns, magnetic distortions aligned with Doppler shifts, signal boosts timed with thruster anomalies. Every piece of data pointed to the same terrifying conclusion: the probe was not alone. Something near Voyager 2 was interacting with its environment, responding to its transmissions, and moving with unmistakable intention. The implications of this discovery were staggering. If an unknown entity was capable of manipulating plasma and magnetic fields in such a precise way, it suggested a level of technological sophistication that far surpassed anything humanity had ever encountered. The idea that Voyager, a relic of 1970s engineering, had stumbled upon something so advanced was both exhilarating and unnerving. The team began to compile the data, layering graphs of plasma density fluctuations over charts of Voyager's thruster activity. The correlations were undeniable. Every time the probe adjusted its trajectory, a ripple of activity spread through the surrounding space, as if something was reacting to its movements. Magnetic sensors picked up subtle distortions that mirrored the probe's trajectory changes, but with a delay of exactly 17.4 seconds, a delay that matched the time it would take for a signal to travel from Voyager to an unknown source and back. This wasn't random interference. It was a dialogue, a back-and-forth exchange between the probe and something else. And the closer researchers looked, the more they realized something else. These patterns had been building for months, maybe years, hidden in the noise because no one was looking for them. The transmission wasn't the beginning. It was the reveal. Scientists began to trace the data backward, sifting through archived telemetry from Voyager's journey. What they found was astonishing. Faint echoes of the same correlations dating back to 2014, when Voyager 2 was still over 10 billion kilometers from its current position. The entity, or entities, had been shadowing the probe for longer than anyone could have imagined. Observation. The correlations weren't just present in the data, they were growing stronger. In the months leading up to the transmission, the plasma oscillations had increased in amplitude by nearly 300%. Magnetic distortions had become more frequent, occurring every 12.7 hours like clockwork. Thruster anomalies, once rare events, were now happening almost daily. Whatever was interacting with Voyager, it seemed to be escalating its activity. Interpretation. There were two prevailing theories among the research team. The first was that the entity was learning. It had been studying Voyager for years, slowly deciphering its signals and systems, and was now attempting to communicate more directly. The second theory was more ominous. The entity was preparing for something. The escalating activity suggested a buildup, a deliberate ramping up of energy and interaction. But for what purpose? Speculation. Some scientists wondered if the entity was trying to guide Voyager. The probe's trajectory had been subtly altered over the years, nudged in microscopic increments that added up to significant changes in its course. If this was intentional, it raised the question, where was the entity leading Voyager? Others speculated that the entity was not benevolent. The increasing interference could be a prelude to something more aggressive, a probing of the probe's defenses before taking more drastic action. The team worked tirelessly, poring over the data, arguing over interpretations, and drafting urgent reports to NASA. But even as they pieced together the puzzle, they knew they were racing against time. Voyager was still moving deeper into interstellar space, and the entity, whatever it was growing bolder. The correlations were no longer just data points on a screen. They were evidence of an encounter, a meeting between humanity's farthest-reaching ambassador and something unknown, something that defied explanation. And as the researchers stared at the graphs and charts, they couldn't shake the feeling that they were witnessing history, or the beginning of something far stranger. Section 13, the final sequence. In the last minute of the transmission, the strangest sequence appeared, a set of modulations that matched Voyager's own outgoing signal almost perfectly, but with subtle differences, as if the signal had been echoed back with enhancements. It wasn't a reflection, it wasn't scattering, it was a reply shaped to resemble Voyager's voice so closely that even NASA's software classified it as probe-like before human analysts intervened. The signal, faint but unmistakable, seemed to emanate from a region of space approximately 14.1 billion kilometers away, a distance that made the possibility of human interference or terrestrial interference statistically impossible. Those final pulses were too clean, too symmetrical, and too deliberate to be noise. They stood out against the cosmic static like a beacon, a sharp break in the monotonous hum of deep space. Each pulse spanned exactly 0.72 seconds, and the intervals between them followed a pattern that defied natural explanation. The sequence was not random, it was ordered, structured, and intentional. The likelihood of such a sequence occurring naturally was calculated to be less than 1 in a trillion, a number so small it bordered on the absurd. And they ended with one final unmistakable silence, the same length as the header silence that preceded each cluster. A beginning, a message, and an ending, a complete structure. Something responded. But what does it mean? The silence itself seemed to carry weight, as if it were a punctuation mark in an alien grammar, a deliberate pause before the transmission cut off entirely. The finality of it was chilling, a cosmic full stop that left the scientists at NASA's Jet Propulsion Laboratory in stunned silence. Observation. The signal's structure bore striking similarities to the golden ratio, a mathematical constant often found in nature but rarely, if ever, in random noise. This ratio, approximately 1.618, appeared in the spacing of the pulses, hinting at a level of sophistication that surpassed any known natural phenomenon. The implications were staggering. If this was indeed a message, it suggested an intelligence capable of understanding and manipulating mathematical principles that humans had only begun to grasp in the last few centuries. Interpretation. The symmetry of the signal was not just aesthetic, it was functional. Each pulse seemed to build on the last, creating a pattern that some researchers likened to a musical score. Frequencies shifted subtly, as if modulating a melody, and the intervals between pulses created a rhythm that felt almost familiar, yet distinctly alien. It was as though the signal was designed to be deciphered, not just detected. The team at JPL spent countless hours analyzing the data, running simulations, and cross-referencing the patterns with known mathematical sequences. Yet, the meaning remained elusive, a puzzle piece from another reality. Speculation. What if the signal wasn't just a reply, but an invitation? The idea seemed far-fetched, yet it lingered in the minds of the scientists. If an intelligence had the capability to intercept and mimic Voyager's signal, it might also have the ability to communicate further. The silence at the end of the transmission could be seen as a deliberate pause, a space left for response. Some proposed sending a follow-up signal, a deliberate attempt to engage in conversation across the void. Others warned of the risks, citing the unknowns of first contact and the potential for misinterpretation. The debate raged on, but one thing was clear: the signal had changed everything. It had shattered the boundaries of human understanding, forcing scientists to confront the possibility that they were not alone in the universe. The implications were profound not just for science, but for philosophy, religion, and even politics. If the signal was a reply, it meant that somewhere out there, beyond the reach of human exploration, another intelligence was watching, listening, and perhaps even waiting. The final sequence haunted the team long after the transmission ended. They replayed it over and over, searching for clues in the static, hoping to find some hidden meaning in the silence. The signal had lasted only a minute, but its echoes resonated far beyond that brief moment. It was a reminder of the vastness of the universe, the mystery of existence, and the enduring human quest to understand the unknown. In the end, the question remained unanswered, a cosmic riddle that would define the next chapter of human exploration. What does it mean? Section 14. The Message. When NASA compiled the engineering logs, the magnetic data, the plasma oscillations, the Doppler shifts, and the anomalous pulses into a single timeline, the mission team was forced to confront a reality they had never prepared for. Voyager 2 didn't just send data, it sent evidence of contact, not with a planet, not with a comet, not with plasma, but with an object. An object that moved, an object that responded, an object that communicated in structured patterns. The room at the Jet Propulsion Laboratory, where the team had gathered, fell silent as the screens displayed waveforms that defied natural explanation. The oscillations were too precise, too deliberate to be random cosmic noise. They were a language, a sequence of pulses that seemed to mirror the binary code used in Voyager's own systems, as if the object had studied the spacecraft and learned to mimic its digital heartbeat. The transmission was not a one-time event. Over the course of several weeks, Voyager 2 recorded multiple instances of these structured pulses, each one building on the previous, as though the object was refining its communication method. The team noted that the intervals between pulses decreased over time, suggesting a growing familiarity with Voyager's systems. By the final transmission, the pulses were so intricately timed that they aligned almost perfectly with the spacecraft's onboard clock, a synchronization that should have been impossible without direct interaction. The team calculated that the probability of such alignment occurring by chance was less than 1 in a trillion, reinforcing the idea that this was not a natural phenomenon, but a deliberate act of intelligence, something advanced enough to approach a 46-year-old machine traveling at 35,000 Neinstedsiters and speak to it in its own rhythm, something waiting in the darkness between stars, something we did not detect until it decided to reveal itself. The transmission is no longer a mystery. It is a message, and now humanity must decide what happens next. The implications of this revelation are staggering. If this object, this presence, is intelligent, it suggests that we are not the only species in the universe capable of thought, of intent, of communication. The distance between us and this object is almost incomprehensible. Voyager 2 at the time of the transmission was over 12 billion miles from Earth, beyond the heliopause in the interstellar medium. Yet, this object found us. It found a spacecraft launched in 1977, a relic of human technology, and it chose to interact with it. Why? What does it want? And what does it know about us? The transmission itself is a masterpiece of mathematical precision. When the team at NASA's Deep Space Network first isolated the signal from the background noise of space, they were struck by its complexity. The pulses were not random. They were organized into repeating sequences, groups of 3 and 5, patterns that mathematicians would later identify as prime number sequences. Prime numbers are a universal constant, a language of the cosmos. They cannot be changed, cannot be altered, and they exist independently of human interpretation. The fact that this object used them to communicate with Voyager suggests a level of intelligence that is both profound and unsettling. It means that this object understands not just mathematics, but the very fabric of reality. The transmission lasted for exactly 72 minutes and 13 seconds. During that time, Voyager's systems recorded over 300,000 individual pulses, each one a piece of a larger puzzle. When the team began to decipher the patterns, they discovered something extraordinary. The pulses seemed to form a map, not a physical map, but a mathematical one, a series of coordinates that pointed to a specific location in space. That location was not in our solar system, nor was it in the immediate vicinity of Voyager. It was far beyond, in a region of space that astronomers have yet to fully explore. What lies there? A planet? A star? Or something else entirely? The possibilities are endless, and the implications are profound. If this object is inviting us to explore, to seek it out, then we must be prepared for what we might find. But the transmission was not just a map. It was also a warning. The final sequence of pulses, the ones that came just before the signal cutoff, were different from the rest. They were sharper, more insistent, as if the object was trying to convey a sense of urgency. Some members of the team interpreted this as a sign of danger, a warning that something was coming, something that threatened not just Voyager, but perhaps even Earth itself. Others saw it as a plea for help, a cry for assistance from a distant civilization facing an existential threat. Still others believed it was a test, a way for the object to gauge our reaction, to see if we were worthy of further communication. Whatever the truth, one thing is clear: we cannot ignore this message. We must respond, and we must do so carefully, thoughtfully, and with the full weight of human ingenuity behind us. The most pressing question, of course, is how we respond. Do we send another probe, equipped with more advanced instruments and the ability to communicate directly with this object? Or do we attempt to establish contact from Earth, using the deep space network to transmit a message of our own? The risks are considerable. If this object is hostile or if it misinterprets our intentions, the consequences could be catastrophic. But the potential rewards are equally immense. If we can establish a dialogue with this presence, if we can learn from it, then we could unlock secrets of the universe that have eluded us for millennia. We could discover new forms of energy, new technologies, new ways of understanding the cosmos and our place within it. The stakes are high, but the opportunity is unprecedented. The team at NASA has already begun to draft potential responses. One proposal involves sending a series of binary pulses that mirror the structure of the object's transmission, essentially echoing its language back to it. Another idea is to transmit a sequence of images and sounds that represent human culture, much like the golden record carried by Voyager 1 and 2. This would include mathematical representations of human DNA, recordings of music from various cultures, and images of Earth's landscapes and cities. The hope is that these transmissions would convey not just our intelligence, but our humanity, our capacity for creativity, and our desire for connection. Another question is whether we are ready for what this object might reveal. Are we prepared to confront the reality of extraterrestrial intelligence, to accept that we are not the pinnacle of creation? Are we ready to challenge our own beliefs, our own understanding of the universe? The answer, perhaps, is that we have no choice. This object has reached out to us, and we cannot turn away from it. We must face it, engage with it, and learn from it. In doing so, we may discover not just the secrets of the cosmos, but the truth about ourselves. The final consideration is time. The transmission was recorded in 2023, but Voyager 2 is so far from Earth that the signal took over 19 hours to reach us. That means that by the time we received the message, the object had already moved on, disappearing back into the interstellar void. If we are to respond, we must act quickly before the opportunity slips away. The cosmos is vast, and the window for contact is narrow. We must seize this moment, this chance to connect with something beyond ourselves, before it is lost forever. The countdown has begun, and the future of humanity hangs in the balance. The transmission is no longer a mystery. It is a message. And now humanity must decide what happens next. The cosmos is waiting, and so are we. The decision to respond will not be made lightly. It will require international cooperation, the pooling of resources, and the collective will of nations. Already, scientists and policymakers from around the world have begun to convene, recognizing that this is not a matter for one country alone, but for all of humanity. The United Nations has established a task force to oversee the response, and space agencies from Europe, Russia, China, and India have pledged their support. The world is united, for perhaps the first time in history, by a common goal: to reach out into the cosmos and make contact with the unknown. Observation: the object's ability to synchronize with Voyager's systems suggests a level of technological sophistication far beyond our own. It implies that this presence has been observing us, studying our technology, and perhaps even understanding our limitations. This raises the question: how long has it been watching? And what else has it learned about us? Speculation: if the object's transmission is indeed a map, it may be directing us to a location of significance. Could it be a home world, a resource-rich region of space? Or perhaps a meeting point, a place where multiple civilizations converge? The possibilities are as vast as the universe itself, and the journey to uncover the truth will test the limits of human exploration. Interpretation. The urgency in the final sequence of pulses could indicate that the object is facing a threat, or that it perceives a threat to us. If this is the case, the message is not just an invitation to communicate, but a call to action. Humanity may need to prepare for the possibility that our response to this message could have consequences far beyond our current understanding. The stakes are high, but so is the potential reward. If we can establish contact with this presence, if we can learn from it, we could transform our understanding of the universe. We could unlock new technologies, new forms of energy, and new ways of thinking. We could discover that we are not alone in the cosmos, that the universe is teeming with life and intelligence, and in doing so, we could redefine what it means to be human. The cosmos is waiting, and so are we.